What's going on, everybody? This is Mr. Williams. This is the video that I'm making for y'all to learn from today while I am gone. Your agenda is right in front of you in brown. You just need to watch this video, finish the backside, work on your IXLs, and if you're done with those, I have a candy challenge linked in the Canvas page that I've set up for today. It's a Sudoku I made last year in honor of Tuesday, February 22nd, being tomorrow. So as far as what we're learning, you can see that it's called one-step inequalities. And that should look familiar. We've done one-step equations before. And as I move down, I hope you're going to see that these look a lot like one-step equations with a key difference that ultimately isn't going to change a whole lot for problems like this. So if you look at the first inequality here with the letter r, with r as my variable, you could probably solve r minus 5 equals negative 7. You probably could solve that right now. And these are going to be very, very similar. Only difference is that instead of an equal sign, you can see we have one of our inequality signs. And you can see that for the other three problems as well. So I'm going to give y'all the basic guide for how to do these. Do the 4 on the front as well as the first 4 on the back. That will leave you 8 problems to finish up during class, and then you can start on IXLs and the puzzle. So this is when I need you to start writing. I'm off my brown pen. There are 3 steps to this. First step, you just pretend it's an equation. So in the case of r minus 5 is less than or equal to negative 7, I'm going to start by changing that inequality sign to an equal sign. And in the examples I do, I would like for you to write this. I'll be checking for that tomorrow when I'm back. But when you start doing these, if you can kind of do this stuff in your head, then that is completely fine. I'm good with that. But I'm just going to change the inequality to an equation. I'm going to pretend it's an equation. Next step, I'm going to pretend it's an equation further by actually solving it like one. So in the case of r minus 5 is less than or equal to negative 7, which I've turned into an equation, I'm going to look and see what's happening to my variable, what's happening to r. I'm subtracting 5 from it. How do I get rid of subtraction? I add. Plus 5 on the left, plus 5 on the right. I copy the variable, I copy r. Plus 5 and minus 5 cancel. And then if I calculate negative 7 plus 5, I have $5. I want to spend $7. I am $2 short. And then my last step is I need to go back to treating it like an inequality. And then I think it will be yesterday that I'll have taught y'all ACP. Answer, circle, point. Named, of course, after my favorite thing to order at Mexican restaurants, arroz con pollo. So answer, circle, point. I'm going to just put my inequality sign back onto this equation. Now I know that r, whatever it is, whatever it could be, it just has to be less than or equal to negative 2. I find my answer, that's the A. I put down my circle, and because my inequality sign has the line under it, I fill it in. There's my C, and then my inequality sign is pointing to the left. There's my P. That's all I do for these. So if I look at this one over here, Z divided by 3.5 is more than 2. If I treat it like an equation, Z over 3.5 equals 2. I'm going to change this back, of course. How do I get rid of dividing by 3.5? I'm going to multiply. Times 3.5 times 3.5. I copy Z. I cancel times and dividing by 3.5. And I calculate that 2 times 3.5 equals 7. Remember to turn this back to an inequality. Z is more than 7. Just put that sign back there. I kind of ignored it so I could treat this like an equation. And now I find my answer. My circle is open this time because my inequality sign doesn't have a number under it, and then my arrow points to the right. Kind of a dinky little arrow. Next one, and I'll zoom out so we can just see all of these together. U plus 11 is less than 15. If I treat this like an equation, make it equals 15 instead of is less than 15. If I want to solve it like an equation, I have my variable. We're adding 11. I get rid of adding with subtraction. Minus 11, minus 11. Those cancel. I copy my u, and I know that that equals 4, except it's not equals. Originally, I had less than in my inequality, so I just need to put that back on. Now that I have the form of the inequality that I can graph, there's my answer. My circle is open because my sign doesn't have the line under it, and my arrow, like my inequality sign, points to the left. And the last one on this page, 8 times something is more than or equal to 24. Now notice I said times. Remember that if a number and a variable are squished together like that, it means they're being multiplied. 8 times u equals 24 if I'm going to pretend that's an equation. I'm going to get rid of times by dividing. 8 divided by 8. 24 divided by 8. 8 divided by 8 cancels. I copy my variable, and 24 divided by 8 I calculate to be 3. Turn that back into the proper inequality sign that I started with. U is more than or equal to 3. Find my answer. Put down my circle, and this time I fill it in because my inequality sign had the line under it, and my arrow points the same direction as that inequality sign. So that's just one example from each operation, one where we saw addition and had to get rid of it with subtraction, one where we saw subtraction and had to get rid of it with addition, and then one each where we saw multiplication or division and did its opposite. I hope by this point y'all are getting the hang of these. Just to be safe though, turn to the back. I'm going to do the first 4 problems, which also represent one problem of each operation. All right, so if I see x plus 7 is less than 12, and at this point I think I'm going to stop doing the equal sign thing. That was to kind of get you used to the idea of solving these like equations, but I'm going to go ahead and stop doing that. But if I see plus 7, if I see that my variable is, or that we're adding 7 to that variable, I get rid of adding with subtraction. Minus 7, minus 7. Cancel, copy, calculate. The sign stays the same. I haven't touched that at all. I guess that might be another part of the copy thing then. But I know that x is less than 5. So there's my answer. My circle is open. My arrow points to the left. So hopping over to my next one, y minus 9 is more than negative 6. I want to look and see that I'm subtracting 9 from that variable. I get rid of subtraction with addition. Plus 9 on the left, plus 9 on the right. Negative 9 and positive 9 cancel. I copy my y and my inequality sign, and then negative 6 plus 9. I have $9. I spend $6. That is $3. And once again, there's my answer. My circle is open. My arrow points to the right. Next, quick example, we see that we're multiplying. 9 times something has to be more than or equal to 36. Notice once again, I said 9 times, so I get rid of times with division. Divide by 9 on the left, divide by 9 on the right. 9 divided by 9 cancels. I copy the z, and I know that's more than or equal to, and then I calculate 36 divided by 9 to be 4. Same process now as before. There's my answer. My circle gets filled in because my inequality sign had the line under it, and my arrow points to the right. And then I'll hop off of this one for just a second. I know y'all can pause your videos. Because down here we have b divided by 3 is more than or equal to -1. How do I get rid of dividing? I multiply. Times 3 on the left, times 3 on the right. Those cancel. I didn't use my colors consistently, but that's fine. I copy my variable. I know that's more than or equal to, and then -1 times +3 is -3. That's the form of this inequality that I can graph. There's my answer. My circle is closed once again because my line or my inequality sign had a line under it, and my arrow points to the right. So that is it. That is all the new stuff I need you to learn today. We'll take some time tomorrow to go over this and answer any questions that y'all have. But thank you guys for your hard work on this. I will be checking for all of this tomorrow. Thank you, and have a good one.